Last week, we saw how we can create an EC2 instance on AWS so that we can use it later to do things with it. And this is what we're going to do this week. We are going to see how we can automate the provisioning of software on our instance so that we can set up a service by simply running a shell script. So we will be doing shell scripting this week. I have my instance running here on AWS. This is the same kind of instance that we have created last week. This is a fresh instance. What we're going to do in this class is basically create and terminate instance many times so that we can practice the automated provisioning. In this case, we are going to provision a simple web service with Nginx. So what I'm going to do is start with a fresh instance. It has absolutely nothing on it. It just has my SSH key set up and a public IP address set up as well, so that I can basically connect to it. That's the starting point we have. So I'm going to change my screen share and switch over to my terminal. All right, so this is my terminal, and I'm going to connect to my instance using my SSH key. So my SSH key has the proper permissions, and I can use it to connect to my instance because I have the IP address in the clipboard. So this is the IP address, the public IP address of my instance on the cloud, and I can use my SSH key to connect to it. And here we go. I'm on my AWS EC2 instance. The first thing that I'm going to do here is I'm going to create my first shell script. And what is really important is that this shell script, I'm going to write it and basically just work on the remote instance. So I'm not going to write it on my computer and then send it to my instance. I'm just going to use text editor on my instance to create my script straight away from my instance directly. I'm doing this because it makes my life easier in order to test what I'm doing. You can also create it on your computer and transfer it using SCP and whatnot. This is a little bit more complicated. I'm going to use VI myself, but you can use Nano, which is a little bit more user-friendly. I'm going to go ahead and create my first shell script, which I'm going to call deploy.sh. And I'm going to write down everything that I want to happen in the shell when deploying my service. I'm going to specify that this is a shell script by writing the first line. My shell interpreter is going to be bash, and I create my script by writing this first line /bin/bash in a specific format using the pound character and the exclamation mark. And that defines what is called a shebang, which basically tells the Linux or the operating system that is going to interpret this text file that this is a shell script that should be run through bash. So that's the first step. And then I can basically just write any kind of commands that I would write in my terminal, in my shell, on my Linux instance, and have them run automatically through bash. So I'm going to install Nginx by using the command apt-get install Nginx. So some of the commands that you are using in the shell are not super compliant with automated scripting. apt is one of them. It doesn't have a stable CLI interface at the moment, so it's recommended that you use apt-get. So this is going to basically just install Nginx, and I could run that script by running it through bash. So I can use bash deploy.sh. As you can see, by just running that command, it's going to look at everything that's in my script file, and it's going to run all these commands. And the first problem we have here is that it asks for confirmation to install the packages. which is not great because we want everything to be automated. So we want as little interaction as possible. Basically, we want no interaction with any kind of human form. So I'm going to stop the script here, and I'm going to adjust my script again. I want to install Nginx and make that so that it's basically automated. So I'm going to add a flag -y, which is going to confirm this. Well, it's going to say yes for me when I get a confirmation message. So this is something that you'll have to do a lot in shell scripting. You have to find the correct combination of flags so that your commands don't have any interaction required. Now, if I run this script again, it's going to install Nginx automatically. And at the moment, it's not great. It's not useful because it just does one command. We could have done it in the terminal, but we're going to add more commands to our script. So for instance, I'm going to create a new file, a new HTML file that is going to be my, well, the page that I want to show in my Nginx service. Because I'm pretty lazy, I'm just going to write some text here, not using the HTML format. And I'm going to use another syntax of shell, or another feature of shell, which is redirection. By using echo it works, it's basically going to print it works on the standard output. And then I'm going to redirect my standard output using this greater than sign, which I may be able to select for you, something like that. And I'm going to create that, well, take that output and write it into a file. So when I use the greater than operator, it will write into a file. So I'm going to write this into my index.html file, and I'm going to run my script again. So now, two interesting things happened. The first thing is that we didn't go through the whole installation process of Nginx. Our Linux system is pretty smart. apt-get realized that Nginx was already installed, so it didn't have to do anything. And then, hopefully, we do have a new file here called index.html. And this file contains the text that we specified in our shell script. Now, that was great. The only thing is that it's going to be pretty hard to debug because we don't basically see anything that happens here. We actually wrote into a file, but it doesn't show up in the output of our script. So in order to make that a little bit more obvious, I'm going to use a flag using the set parameter in my script. And I'm going to use set -x, and this is going to make my script output on the terminal every command that it is going to run. So that's going to be very helpful to debug our scripts. So now I added that flag, and if I run my script again, you'll see that first I'm going to do apt-get install Nginx, and then I'm going to echo it works, and this is going to be redirected into my file. The set command is very useful, and you can use it for other things. The typical combination of flags that I suggest is -uex. X does the output of the command every time it runs a command. E is very useful too. It basically will stop the execution of the script as soon as you will have a command that does not return an OK status, so which is 0 error code in POSIX terminology. So for instance, if I type here a command that doesn't work, or I make a mistake, like a typo, for instance, I use LSA instead of LS, then when I'm going to run my script, my LSA command is going to be not found, and that is going to stop the execution of my script. As you can see, it does not echo anything. It stops here because that command is not found, and because of that, it will stop the execution of the script. So that's very useful. Sometimes, and well, a lot of times in shell scripting, you want to be absolutely sure of what's happening in your script, and you don't want to keep going if you are in an unpredictable state, such as what would have happened here if the command would not have run as expected. So it's always a good idea to use -e as well. And -u is useful when you start using variables. So I'm going to use a variable here. I'm going to define a new variable called package name, which is the name of the package that I want to install. And I'm going to use that variable in my command here. So that's something that you can do in shell scripting. You can use variable names in your commands by prefixing them with the $sign. And what this is going to do is that it's going to replace the value of the variable into the command. So it's going to basically do sudo apt-get install nginx, but now we control the name of the package using a variable. We can run it again. Oops. Well, this command is not found, so that stops the execution of the scripts. That's a bug. I'm going to fix it by removing the useless command, and I'm going to run the script again. You see that I define a new variable in my script, and the very useful stuff about set -x is that it will show you the variable replaced in the commands that it's going to run. So here, because I use package name, the value has been replaced by nginx, and it's going to run the command once again. Something that is also useful when dealing with shell variables is to use the squarely brackets, curly brackets, I don't remember how you call them, because that will help you define what is a variable, what is part of the variable name, and what is not part of the variable name. This is very obvious when you do something like this. I am going to install. So this is pretty straightforward, but now if you want to continue the sentence, I am happy that it worked. We may have sort of an ambiguity here. Is the dot part of the variable name or not? That could be very confusing. So in order to make it very obvious, we are going to use the brackets to specify that the name of the variable is actually just package name, and the dot is part of the string that you want to display. Let's see, run this. Okay, so it's going to install nginx. It hopes that it's gonna work. And now we are going to install nginx, and then we echo it works into our HTML file. So that's pretty good. What I wanted to show with the -u is that if you make a typo or a mistake, for instance, have fat fingers, so I may have typed package name something else, or even here, package name, I made a mistake here and there too. With -u, we are going to stop the execution of the script as soon as we encounter a variable that is not defined. Here we have an unbound variable, so the script stops because package name with 2 A's is not known to Bash when running the script. If we didn't use -u, so I'm going to remove it here, and we run the script again, we have a lot of issues because now it's going to install -y nothing. It's going to say echo it works, but actually it's going to install, well, this is not good. So this is something that you can avoid by using -u, because the script will stop as soon as you encounter an unbound variable. Now that we have a little bit of scripting under the hood, we can actually start doing something a little bit more useful. We are going to edit the script. It creates an HTML file, and what we're going to do now is put that HTML file into the correct location for Nginx to serve that file. As it happens, the location for Nginx on this version of the Ubuntu package is going to be /var/3w/html. You may want to check that in the Nginx configuration file by checking the root folder of your Nginx configuration file, which is /var/3w/html. And you probably have index option set, which tells you that you want to look at the following files in order when serving a directory that from your Nginx. So basically index.html should be good. So we want to put index.html into /var/3w/html, which is what I wrote here by saying I want to copy index.html in the current folder into /var/3w/html. So let's run this. Oh, my script has bugs. I need to fix them. Well, this is not very useful. I have to move it. Okay. So I fixed my variables and I can run my script now. And now it actually doesn't work because I'm trying to copy a file into /var/3w/html, and I get a permission denied on that command. The reason for that is because, and this is very common in shell scripting, my /var/3w/html is owned by the root user and the root group. And the permissions for this folder are read write for the owner, and for the group and everyone else, it's just read and execute. So we cannot write or we cannot create a file in that folder because we are, oops, my bad, we are the Ubuntu user. So Ubuntu is not root. We are the Ubuntu user. These are our groups, and none of them actually matches with root. So we will have permission denied. So there are lots of possibilities here that we can follow to fix that. We could decide to change the permissions of the /var/3w/html folder and give them to the Ubuntu user, or we can run the command through sudo, and that will give us root permissions on the command that we are going to run, allowing us to copy the file into that folder. So this is what I'm going to do. And here I'm going to prefix my command by sudo. So as a general rule, you don't want to use sudo without thinking about it. You should use sudo only when it's strictly necessary, because sudo runs a command with administrative privileges, which can lead to security risks. So in this very case, I need to have my permission set up, or I need to have root permissions in order to copy my HTML file. So I'm going to use the sudo command. I'm going to run the script again. And now I don't have any errors anymore. And I could have a look. Let me just change my screen sharing. Right, I used incognito browsing here to make sure that my page was not cached or anything like that. And now if I load the IP address of my instance in my browser, I can see that it actually worked, and I see the HTML page that I created, which is it works. So that's something good. And this is what we want to do, and we are going to expand on it. You are going to expand on it in the lab by doing more things than just copying an HTML file. So now the situation that you're dealing with is that you've run that script on your remote AWS EC2 instance, which means that this script needs to be available on your instance in order for you to run it. And because we want to automate as much as possible, We don't want to copy that file manually, and you just want to be able to run a script from your own laptop. So we're going to look at how we can do that by going back to the terminal. And so these are the files I have, deploy.sh and my index.html. Once again, what's going to happen in the long run is that you're going to create an EC2 instance and you are going to run a command on your laptop and everything is going to work fine. So this is our objective. So we cannot expect the script to be on the EC2 instance. So we are going to work on our local workstation now. So I disconnected from my AWS instance, and now I want to work on my workstation so that I can do bash, whatever, and it connects to my EC2 instance, copies the files, and whatever I want my script to do. All right, so how are we going to do that? There are two strategies here, and you can have a lot more details on my website, which I'm going to show. All right, I need to change my screen share. That's it. Okay. Yes. So you have two ways of doing it. Either you create two files. One file is your entry point script, which is going to run on your laptop. And this script is going to copy another file to your EC2 instance and run it on the instance. So basically the script that I created, deploy.sh, you create another script that copies it from your laptop to your instance and runs it on the instance. So that's the strategy 2. You copy a script over to your instance and run it on the instance. There is another strategy, which is, in my opinion, not as good, which is to write everything in one single script, and basically you do all your commands through SSH or through SCP. I find this one less easy to maintain, but it works as well. I'm going to use strategy number 2 here because I already have some starting script that I wrote on my instance. So here I'm going to do a little bit of Linux commands, and the other, so you've done SSH, and the other command that we're going to use is SCP, which allows you to copy files to and from remote Linux or POSIX compliant machines. So I know for a fact that on my remote instance, this IP address, I started working on a deploy.sh script, which worked well and was doing most of what I want it to do. So what I'm going to do now is use SCP to copy that script from my instance to my local workstation so that I can keep working on it on my local laptop. I'm going to use SCP for that. And SCP takes an identity using -i, and then it takes a source and a destination. It's very much like the CP command, except that the source and the destination can be remote. So in my case, I'm going to copy from the remote instance on AWS, Ubuntu user at the IP address of my instance, and then I use colon and the path to the file that I want to copy. So here you have to think about your Linux skills. By default, when I'm going to log in into that machine, I will be put into my home folder /home/Ubuntu. So I can just refer to my deploy.sh script as deploy.sh. If I would have put it in a different location, I could have wanted to use a full path starting with / to my script. For instance, /work/in progress /deploy.sh. All right, this is very important working with path. This is usually a problem. So I'm going to copy my deploy.sh, which is going to be in my own folder, and I'm going to copy it into my local machine. So I'm using dot here because dot is a shortcut for the current directory. So the directory that I'm in. So if I run this command, I will copy the file from my EC2 instance to my local workstation, which is what just happened. Now, if I look at my files here, I now have my deploy.sh, which is the file that I started working on my remote instance. So now I'm going to do strategy number 2. I'm going to create another script that is going to copy this file to my instance and run it on my instance. So because I have some kind of OCD with file names, I find it easier if my scripts have very explicit names. So I'm going to call this deploy on remote because that's going to be run on the remote machine. And here I'm going to create a new script called deploy.sh. Start with the shebang. And now our work is pretty simple. We want to copy the deploy on remote shell script to our remote target, and we want to run that script on the remote target as well. So we could start with writing the SCP commands. So this is, I want to copy using my private key file. And this time I'm going to copy from my laptop to my remote target, my Ubuntu instance. So first file is going to be my local file, deploy on remote. And my target is going to be Ubuntu. And I'm going to copy, well, I'm going to leave the path empty here. So it's very tricky. My line ends up with better here. My line ends up with a colon. And I didn't specify a path. So by default, it's just going to go into the home folder. But I need the colon. Why do I need the colon? Because you don't want to do that. Deploy on remote. If you forget the colon, now you have a file called Ubuntu at whatever, which is not what you want. So make sure, oops, apologies, that you don't forget the colon here at the end of the line. So what this is going to do is that it's going to copy the file over. And now we want to SSH to the remote target. And if we could stop making so many typos, that'd be great. And we want to connect to the target. And now we want to run the command. So we want to run bash deploy on remote.sh. So this can only work if you have copied the file earlier, because you cannot expect the file to be on the remote machine. Now, best practices, let's add a couple flags here to make sure that everything's fine. And let's see what that does. Well, okay, so it's copying my file over. And it's going to install Nginx, which is already installed, and it's going to echo it works into the HTML folder, and it's going to move the HTML file to the correct folder. All right, well, that's decent. What we could do is improve this a little bit. We could define variables here. It's very easy to make a mistake. Very soon, I'm going to terminate my AWS instance, and I'm going to recreate a new one to make sure that everything works as I want. So my IP address is going to change. And I don't want to go through all my scripts and change my IP addresses in all kinds of locations. So I'm going to use remote host. And I'm going to use a variable for that. Remote user will be Ubuntu. And well, that should, well, and my key file. That's always useful to have in a variable as well. 4640, whoa, 4640 key.pdm. Let's put that in that order. And let's replace things here with the correct variables. So now you see why it's good to use variables. If I ever change my key file, I just need to change my variable at the very top of my script, and everything else will be adjusted automatically. And here I probably want to replace that's sure. Oh well, that worked. And I want to replace my IP address with my nice variable. Well, no, that's not what I wanted. I bet. Obviously, you can use whatever technique you want to edit your shell scripts. You don't have to use VI, but I have to admit that it makes your job easier in the long run. Okay, so we have our script here. Let's try to run it and see what happens. Okay, it seems to still work. I'm not really happy about that. There is no real reason to create a file and then copying it over. We would be better off just echoing into that path. However, what I'm going to do actually is create my own HTML file, because I don't want to echo anything into a file, because my HTML file would probably be something a little bit more consistent, or maybe the output of a build pipeline or whatnot. So I'm going to create an HTML file and then use it in my script here, rather than echoing into my HTML file. All right, so what I've done is that I used my great HTML skills by downloading a template that has very nice HTML in it that comes from Bootstrap. And I put that into an HTML file that I called bootstrap.html on my local machine in the folder that I was working in. So I customized the HTML so that, oh, I'm going to do something even fancier. I'm going to put that into a container. All right, that's going to be great. So this is my HTML file. It's not very interesting, but it's just for the example. And now what I want to do is adjust my script so that it copies that HTML file instead of echoing into my into a local file on my remote target. So in order for that to work, I would need to copy the HTML file as well. So not only will I copy the script, but I will also copy my index.html file. And then I'm going to run my deployment script. So obviously I need to adjust my deployment script as well and make sure that I'm not echoing into my HTML file, but I'm basically grabbing the HTML file and put it in the right location. I'm going to remove this, and I'm going to sudo cp bootstrap.html. And because I don't want the file to be called bootstrap.html, I'm going to adjust my script and call it index.html so that it keeps, it still works. Okay, well, let's try it out and see what happens. Oh, well, that didn't work. Why did that not work? Ah, because the file that I want to copy is called bootstrap.html. And for some reason, I try to copy index.html. So this is, as I said earlier with path, it's a very typical mistake. I make mistakes all the time. Make sure that you double check your file names, your paths, etc., etc. It's very easy to make mistakes, and I'm the perfect example of a mistake. All right, so let's run it again. Okay, and this time it's working. So this is a good example of why we should use set -e. When I run it earlier, there was a mistake. My index.html was not found. So it did not copy the file over, and it stopped the execution of the script. And I'm thankful for that, because it did not keep on trying to deploy my application, which would have been a bad idea. Now that I fixed it, it looks like everything has worked as expected. So I should be able to open my web browser here. And I can see the output of my HTML. Yes. So, oh no, this is the. All right. See, okay. Yeah. So I just run the script, and now I have this nice HTML front-end page looking on my remote target. And this was all done through my set of scripts, one running on my laptop and copying all the files required, and the other one running on the remote target. So this is what you can work on. I'm going to expand a little bit on a couple of tricks that are useful when doing shell scripting, but this is the most important bits that you need to remember for this scripting exercise. So now that we have everything working, we can test that everything worked fine. And this is going to be a little bit time consuming, and we'll see how we can expedite the process a little bit later in this course. What I want to do is run my script on a fresh instance that doesn't have anything on it, just to make sure that it works as expected. So I'm going to terminate this instance, and I will run another one. So I'm skipping through these screens because you know them already. Okay, so now my instance is launching. Oh, I forgot to give it a name. Let's do that now. I'm going to add a new tag. To test script. To be very obvious which one is which. Okay, so this is going to be my instance. This is going to be the IP address. I'm going to copy it, and now I'm going to wait for this machine to be up. So something like that. Okay. Well, you can see the terminal. The machine is not up yet. I cannot connect through SSH. Oh, it's up. Let's move to my terminal. All right. So I can SSH to my instance because it's up and running. So the first thing that you see is that it's asking us again about this key stuff that I talked about last week. And if you think about it, this is not going to be good for us if you want to do everything automated, because it's basically waiting and halting the execution of our script, because it's going to ask the user for a confirmation on whether or not they want to keep connecting to that instance, to that machine. So So if I run my deploy.sh, I don't see it here, but this is why it's not happening. It's basically stuck at the host key verification step. So what I want to do here is make sure that when I use the SCP and SSH commands, I'm not paying attention to or not taking care of the host key checking stuff. So you have examples on my website on which options you should use. It's basically strict host key checking and use unknown hosts file. And you can just stick them in your SSH command or SCP command like this. And this is where you're happy that we're using shell scripts, and they both work for SSH and SCP. So that's pretty good. Now, as you can see, this is not great. So what I suggest, and there are all kinds of different ways to do that. The way that I'm using here is okay, but you may want to do an actual function in the long run. But here, basically, we are going to create variables that will help us work with SSH options. Let's do something like this. SSH options equals. Oh, that's actually a better idea. Okay, and let's do this. And now we can do SCP SSH options. Oh, SCP SSH options here. Try that. SSH options. That's easier to read and easier to manage as well. And if I didn't make any mistakes, everything should still work. Well, obviously, I would need to adjust my IP address with my new IP address, which is here on my EC2 dashboard. Okay. All right. So now we have slightly better script, I believe, and we should be able to run it. We could use a -q here to remove the warnings from SSH. But yeah, so now it's installing Nginx. All of that happens automatically. And it's also copying my HTML5 to my HTML folder for Nginx. And now I can open this in a browser and everything is working. So this is great. And this is what I wanted to happen. Now, this is good. I'm going to tell you about a couple of things and a couple of tricks about shell scripting, maybe some traps. The first one that I already talked about is the fact that once you've run that script once, there are things that have happened on the remote target, and you may want to account for them. So the idea is that you can run your script over and over again, and you will always get to the same result. So that's called idempotence. And it means that whatever you do with that script, if you run it several times, it always works and it always gets you to the state that you wanted. So in our case here, we didn't do anything complicated. So that was pretty easy to manage. But if to do something a little bit more complicated in your deployment script, which is something you'll have to do in the lab. Let's say, for instance, you create a new user called Tim. Okay, so I can run this script again. It's going to run with the new version of my deploy on remote.sh. And it's going to add that user Tim. Now, if I run it again, my user Tim already exists. And this seems very obvious, but sometimes you can forget about this. Once you've run your script once, the state of your remote target is not the same as before. So here, because we use -e, this user add commands does not complete successfully, and the execution of the script stops, which is not good. So here we have all kinds of ways of fixing it. One way would be to disable the set -e flag before we run that command. That would not be a very good idea, because basically you want to have your script that just works. What we can do is think about what happens behind the curtains when we run that command. So when we do that, as in every command run on the Linux, well, on a bash environment, this command, when it completes, will have what we call an exit code. And the exit code will be 0 if everything went fine, or it will be something else than 0 if it didn't work as expected. The exit code is stored in the $? Special variable. So here it failed with exit code number 9. It's not 0, so it failed. So that's something that's how set -e works. For each command, if it does not have an exit code of 0, it will stop the execution of the script. So how can we make sure that we don't run into that problem? One idea would be to first delete the user, and then we can recreate the user. This user may have some important files that you don't want to remove. So maybe this is not the best idea. So what we want to do is make sure that your user does not exist already before creating it. So one way, and this is specific on all kinds of commands, it depends on the command that you're trying to run. But here, the problem that we're trying to fix is we want to know whether or not the team user already exists on the remote target. And the command to tell us that is ID. ID will tell us if the user exists. And ID will return an exit code of 0, meaning everything went fine if you query a user that does exist. If you query a user that does not exist, you will have an error message, and the status code is going to be not 0. It's going to be 1. So now you can use that in your script to have a sort of a condition that will decide whether you want to create that user or not if it does not exist. So I can exit, come back to my shell script. And in my script, local script here, I'm going to use a condition, an if statement, to check whether my team user exists or not. So I'm going to use if, and I'm going to run the id team command. So this is a simple if statement in Bash. And what this block does is that it's going to run the id team command, and whatever status code is going to come back is going to be evaluated in the if statement. So if, and this is what I was doing here, if ID team, meaning that, so here my user does not exist. So this command is going to return a status code which is not 0. And then because we use the square brackets to test the values, then we are going to test that this is not 0. And because it's not 0, it's not going to match the conditional statement. So the ls here is not going to run. Basically, you can see that as if that command does work, then run this. Otherwise, well, don't run it. So in that case here, because the command ID team does not return a status code of 0, then ls is not going to run. So in our script here, if we do that, ID team does not exist, then this is not going to run. So here we need to negate the condition, because we want to make sure that if ID team does not exist, then we actually run the command. And here we can add a little bit of else, say go team user already exists. Okay, so here my user does not exist, so I can try to run my script. And the user has been created because my ID command, well, told my script that this user did not exist. If I run the script again, now it checks that this team user already exists, and it does see it. So now it does not create the user again. Okay, my bad. I stopped the recording and I still had things to say, so this is going to be a little bit weird. Sorry about that. So what we are doing here actually is that we are looking at the actual output of the command. So this is something that is a little bit tricky to understand as well. When I use the back quotes here, it makes the shell run the command, and it's going to inspect the output and not the exit code. So what I said earlier is that it was checking the exit code is not entirely true. I was just trying to introduce the conditional statements to you guys. So as you can see here in the output, it's actually comparing the output of the command ID, and it's not using the actual exit code. So now we can work with the exit code itself for real. So now we can use the exit code itself. So now what we're going to do is we're going to run the command ID team, and we are going to check whether or not that command return a status code of 0. So if I'm going to use EC here because that works well. I'm not sure how you guys are familiar with bash scripting with 2 square brackets and 1 square bracket, but you can look at that in your free time. So now what we have here is that if the status code was 0, which means that the command successfully completed, we don't want to create the user. So we actually want to, if the status code was not 0, then we want to add the user. Otherwise, the team user already exists. I can run my script again. Now we have, we use the status code properly. And then the next thing that we are going to do, we don't want to have this in the output of our script, which is the idteam command. So what we are going to do is redirect this command into /dev/nil, because we are not really interested at the output. We just want to know the exit code. And just to be on the safe side, I'm going to remove that user from the target before I run my script again. Ah, that's interesting. So now what happened is that my script stops because I'm trying to do idteam and my command does not return a status code of 0. So because I have set -e, the execution of my script also stops. So this is something that, and this is why we're going to try to move away from shell scripts as soon as possible. This is something that you'll have to deal with manually. So for instance, here, what you could do is change the set option to ignore invalid status codes, exit codes, because we are checking it ourselves. So we can assume that everything else will be fine. Now I have something else that is happening. I still have the output. So this is coming from the fact, and here I'm not going too much in details, but I'm hoping that your Linux courses from 2420 told you that. The standard output of the command is being redirected to /dev/nil. We want to redirect the standard error stream as well by using number 2 and sending it to the same as number 1. So I'm going to remove everything. Okay, probably a mistake. Yes, I did make a mistake. My script was not working well, and this is because set is a bash command in itself. So if I use this, when set -e is being run, it returns 0. So my user will never be created. So I need to re-enable my exit on error after I've done the check of my status code in my if block. Make sure that my user is deleted. I'm not sure why my SSH connection broke. Okay, and now you can see that this user has been created. If I go back to my instance, idteam, my user is created. If I run my script again, then my team user already exists. Okay, so I think that's about it. This is what you're going to work on in the lab. In the lab, you will have to create a script that is going to connect to your instance and set up Nginx in this way. So you will have to create a couple of folders, create a user, etc., and try to make it as idempotent as possible. And this lab is not graded. It's probably written somewhere. You can work on it. It's basically experiment, refreshing your Linux shell scripting skills. What's going to happen though is that the week after, I will give you an exercise during class time with limited time, where you'll have to write a shell script. So it's not going to be about a completely full application. It's going to be similar to Nginx, rating users, dealing with files and folders, etc., etc. And then we will work on a full application. So make sure that you practice this week using variables, using redirections, SCP, SSH, running all kinds of stuff, so that next week you are not stuck in the in-class evaluation.